Math 1630, Finite Mathematics, Module 1, Section 1.1, Linear Equations and Inequalities. Objectives. Objective 1, solve linear equations. Objective 2, solve a formula for a particular variable. Objective 3, solve and graph linear inequalities. Objective 4, solve applications involving linear equations and inequalities. Objective 1, linear equations. In general, a linear equation in one variable is any equation that can be written in the form ax plus b equal to 0. A is not equal to 0. This is called the standard form of the linear equation. For example, the equation 2 multiplied with x minus 3 plus 5 equal to 7 is a linear equation because it can be simplified to the standard form. Equivalent equations. Two equations are equivalent if one can be transformed into the other by performing a series of operations which are one of the two types. 1. The same quantity is added to or subtracted from each side of a given equation. For example, 2x minus 5 equal to 12 is equivalent to 2x minus 5 plus 5 equal to 12 plus 5. Each side of a given equation is multiplied by or divided by the same non-zero quantity. Example, 3x equal to 9 is equivalent to 3x over 3 equal to 9 over 3. To solve a linear equation, we perform these operations on the equation to obtain simpler equivalent forms until we get the solution. The steps to follow to solve a linear equation. 1. Simplify the algebraic expression on each side by removing grouping symbols and combining like terms. Collect all the variable terms on one side and all the numbers or constant terms on the other side. Isolate the variable and solve. And finally, check the proposed solution in the original equation. Here is an example. We need to solve 8x minus 3 times x minus 4 equal to 2 times x minus 4 plus 5. We simplify it like this. 8x minus 3 multiplied with x minus 3 multiplied with negative 4, that is positive 12, equal to 2 multiplied with the x, which is 2x, 2 multiplied with the negative 4, which is negative 8, plus 5. Now combining the like terms, we get 8x minus 3x, which is 5x, plus 12, equal to negative 8 plus 5, we can combine it as negative 3. So this side will be 2x minus 3. So we are going to subtract 2x here, and 2x is subtracted on the other side too. So getting 3x plus 12 equal to negative 3. So now we can subtract 12 from both sides, getting the equation as 3x equal to negative 15. So to get the x, we need to divide both sides by 3. So getting negative 15 over 3. So the answer will be negative 5. Now we are going to check the answer by substituting in the original equation. 8 multiplied with x value is negative 5 minus 3 multiplied with negative 5, negative 4 equal to 2 multiplied with the negative 5 minus 4 plus 5. If we simplify this, we will get negative 40, negative 3 times negative 9. On the other side, we will get 2 times negative 9 plus 5. So we are checking whether these two sides are equal. And this will be negative 13 and this is also negative 13, so both sides are equal, so it checks. Objective 2. Solving a formula for a particular variable. Solving a formula or an equation for a specified variable is done the same way as solving an equation for the variable. When solving a formula for a specified variable, treat the other variables as if they are numbers. Here is an example. We need to solve for n from the equation m equals nt plus nr. We factor out the n and write it as n multiplied with t plus r. So in order to solve for n, we can divide both sides by t plus r, getting n value equals m over t plus r. Objective 3. Linear inequalities. If the equality symbol in a linear equation is replaced by an inequality symbol, less than, greater than, less than or equal to, or greater than or equal to, the resulting expression is called a first degree or a linear inequality. These are some examples. X is less than 5. 2x minus 4 is greater than or equal to 6. Solving linear inequalities. A solution of an inequality is any number that makes the inequality true. We can perform the same operations on inequalities that we perform on equations, except that the sense of inequality reverses if we multiply or divide both sides by a negative number. For example, if we start with the true statement negative 2 greater than negative 9 and multiply both sides by 3, we get the inequality negative 6 is greater than negative 27, which is true. The sense of the inequality remains the same. If we multiply both sides by negative 3 instead, we must write 6 less than 27. The sense of the inequality reverses this time because we are multiplying with the negative 3. Solve the inequality 3 multiplied with x minus 1 less than 5 multiplied with x plus 2 minus 5. 3 times x is 3x. 3 times negative 1 is negative 3. Here also we are going to distribute. So we get 5x plus 10 minus 5. So then we combine like terms. 10 minus 5 will become 5. 3x minus 3 is less than 5x plus 5. If we subtract 5x from both sides, we get this 5x cancelled. So this left side will be negative 2x. We can also add a 3. So this 3 will be cancelling. So we get negative 2x less than 8. So if we divide with the negative 2, the inequality will be reversing. So we get 8 over negative 2, which is negative 4. So this is where the inequality reverses. Interval and inequality notation. If a less than b, the double inequality a less than x less than b means a is less than x and x is less than b. So that means that x is lying between a and b. So these are some of the interval notations. The important thing is when there is less than or equal to, the interval notation requires you to use square bracket. When there is strict inequality, we need to use parentheses. And in the case of infinity or minus infinity, we always use the parentheses. Parenthesis means that point is not part of the set. Square bracket means that is part of the set. Interval, inequality notation, and line graphs. So we have two examples here. We need to write the interval negative 5 to left closed right open as a double inequality, and we need to graph it. This interval is equivalent to negative 5 less than or equal to x less than 2. Notice that the square bracket corresponds to less than or equal to, open parenthesis corresponds to less than. So to graph this, we draw a number line, mark these 2 points, and then use the square bracket for inclusion, open bracket for strict inequality. We are speaking about x lying between these 2 points. We need to shade this in between region. In example B, x is greater than or equal to -2, so that is equivalent to closed interval -2, comma infinity open. Graph will be -2 close bracket, infinity is on this side, so we need to shade this right side here. Solve and graph. -3x plus 5 is greater than -7. So first what we do is we subtract 5 from both sides. -3x plus 5 minus 5 is greater than -7 minus 5. So then this 5 will be cancelling. We get the inequality -3x greater than -12. So to get x, I need to divide both sides by -3, and dividing with a negative number, therefore the inequality will be reversing, and this simplifies to x on one side and 4 on the other side. So we get x less than 4 as the solution, and we get the graph form. For here, this is strict inequality, so we use the open parenthesis. Then we need to shade the left side. Interval form will be -infinity 4 open. So this is the interval form, this is the inequality form, and we do have the corresponding graph here. Example 2. We have a compound inequality here, 2 less than 4 minus 2x less than or equal to 6. We are going to subtract a 4. So -4 comes in here too. So this 2 will be -2. This 4 will be cancelling. So we get less than -2x less than or equal to 2. So now to get x, I need to divide with the -2. So I'm going to divide -2 less than -2x divided by -2 less than or equal to 2 divided by, but notice that this inequality has to reverse, so I need to actually change this. So this is not the right one. Greater than, this will be greater than or equal to. That is because we are dividing with the -2. So we get the inequality as 1 greater than x greater than or equal to -1. So 2 divided by -2 is -1. -2 by -2 is +1. We can rewrite this as -1 less than or equal to x less than 1. So that is one answer form. And we can also write this in the interval form. -1, 1 with a closed bracket on the left, open bracket on the right. Less than or equal to refers to square bracket, less than refers to open bracket. Here is an example of an inequality with the fractions. So we need to solve this inequality. M by 2 minus 3 is greater than 3 over 2 minus m over 3. So we take the LCD of the denominators. So we have the denominators 2, 1, 2 and 3. So the LCD is going to be equal to 2 times 3 equal to 6. Then what we are going to do is we are going to multiply with 6 on both sides of the inequality. 6 is a positive number, so we have the same inequality direction. So 6 multiplied with m by 2 minus 6 multiplied with 3 is greater than 6 multiplied with 3 by 2 minus 6 multiplied with m by 3. So when we simplify this, we will get 3m minus 18 is greater than 6 and 2 cancel, so you'll get 9 there minus 2m. So now we can actually add a 2m here, add a 2m on the other side. This cancels, add a positive 18. So negative 18, positive 18 cancels. We get 5m is greater than 27. So divide with 5. 5 is a positive number, so we will get 5m divided by 5 is greater than 27 divided by 5. 5 cancels, getting m greater than 27 by 5. So that will be the answer there. Objective 4, application problems. Break-even point. If R represents the revenue and C represents the cost, then the break-even point is the point where R equal to C. Generally, cost involves both the fixed cost and variable cost. So cost function, cost equal to fixed cost plus variable cost. Example, break-even analysis. A record company produces compact discs. One-time fixed cost for a particular CD are $24,000. This includes costs such as recording, album design, and promotion. Variable cost amount to $6.20 per CD and include the manufacturing, distribution, and royalty cost for each disc actually manufactured and sold to a retailer. The CD is sold to retail outlets at $8.70 each. The question is, how many CDs must be manufactured and sold for the company to break even? Here is a solution. We assume that X is the number of CDs manufactured and sold. So the fixed cost is given, so which is 24,000. Variable cost will be multiplying the number of CDs manufactured with the cost of manufacturing one CD, which is 6.20 multiplied with the X. So the cost function will be cost equal to 24,000 plus 6.20x. The revenue is calculated as the total sales, so that will be 8.70 multiplied with the x. In step 3, this condition that the revenue is equal to cost. So revenue equal to cost means that 8.70x equal to 24,000 plus 6.20x. This is the equation which we need to solve. So to solve that, we subtract 6.2x from both sides, getting 2.5x. So 6.2x subtracted. So to isolate the variable, we are going to do that step. So we will get 2.5x equal to 24,000. So then we are going to divide both sides by 2.5. So here also we are going to divide 2.5. So on the left side we are going to cancel 2.5 and getting x. On the right side we do this arithmetic. 24,000 over 2.5 is 9,600. Now remember that x is standing for the number of CDs. So the answer will be 9,600 CDs to break even. Here is another example. To determine the number of trout in a lake, a conservationist catches 660 trout, tags them, and releases them. Later, 130 trout are caught, and it is found that 55 of them are tagged. Assuming that the proportion of tagged trout in the second sample was the same as the proportion of tagged trout in the total population, estimate the number of trout in the lake. So here we are assuming that the two proportions are the same. Proportion of tagged trout in the same second sample is the same as the proportion of the tagged trout in the total population. X to be the number of trout in the total population. So then we are going to equate the two ratios. So 660 is the sample that are tagged. So that will be proportional to x, and that will be equal to 55 of the second sample were tagged. So we had 130 in that sample. So the ratio will be 55 out of 130. So these are the two proportions equated. 660 out of Ax will be 55 out of 130. So we are going to solve this equation for Ax. So basically solve for Ax. So we can cross multiply and get the equation as 55X equal to 660 multiplied with 130. So to get X, I'm going to divide both sides by 55. So X value will be equal to 660 multiplied with 130 divided with the coefficient, which is 55. So when we do this calculation, we get the number as 1560. So the answer will be 1560 trout in the lake.